A very warm welcome to this first S1 Parent and Carer workshop. My name is Callum Blair. I am the curriculum leader for computing and maths here at Knox Academy, and this is going to be the first of 5 sessions, and in this one we're focused on negative numbers. In the assessment that pupils sat fairly recently, there were aspects of negative numbers that were really strong, and there were some aspects, like the questions on the screen at the moment, that pupils found a bit more difficult and a bit more demanding. So we are going to focus a lot of this session on these types of questions, but we will cover the whole spectrum of what we have taught in S1 Maths related to negative numbers. In this workshop, we're going to look at what a zero pair is. We're also going to look at adding a positive and a negative number, and how we minus. But first of all, what we're going to look at is multiplication and division. Now, within this workshop, I will illustrate a number of the things that we do in the maths classroom, and I will use some of the same slides and the same materials. We use 2 colour counters to help students understand negative numbers and the methods that we want them to learn about. These manipulatives are very, very useful in the maths classroom. It almost brings the maths to life instead of all being on paper. These manipulatives have also been very carefully chosen because they're useful throughout the curriculum, so it allows pupils to see the connections across different topic areas. And hopefully those connections help make more sense of the maths that they're learning. So first of all, let's look at multiplication and division. This slide here is an example of our learning intentions and success criteria that we share with pupils at various points through the lesson. So in the box we have a couple examples of the type of learning that they are going to be doing, and on the right hand side we've got the success criteria. Now, I wouldn't normally introduce this at the start of the learning. This would be at the end of the learning, where we co-construct the success criteria with the young people in the class. So straight to it. 3 times 2 is the same as 3 groups of 2. Using these 2 colour counters, there is my 3 groups of 2. Introducing negative numbers, so we're building from something that should be familiar to all the young people. 3 times 2. We're now looking at 3 times negative 2, so that's the same as 3 groups of negative 2, and that's what 3 groups of negative 2 would look like. So that in itself seems and feels hopefully fairly straightforward. But what about negative 3 groups of 2? How would we illustrate that and show that using these manipulatives, using these counters? Well, we can't really show negative 3 groups of any quantity, so we have to change that. There has to be a way to show it. We have to change it, and this is how we would change it. We would do the negative of 3 groups of 2. So the negative of 3 groups of 2. So it's essentially constructed using the same terms and symbols. We have the 3 times 2 in both the black and the red, and we have 1 negative there. So it's the negative of 3 groups of 2. So what that means is we work out 3 groups of 2 and then flip the counters. We change the colour. So there's the 3 groups of 2, and if we flip that group, we have 6 reds. So that would be an answer of -6. So what we tried to do is ensure that we have these consistent models and metaphors throughout the curriculum. We don't have different rules for different things. We try to keep that as consistent and as minimal as possible, so pupils don't feel that it's all to do with what they can and what they can't remember. So the negative of there, just to emphasize, really means we flip those counters. So let's have a look at a few examples together. Calculate -3 times 5. So that's the same as 3 times 5 flipped. Well, 3 groups of 5 would look like that. So the negative of, or that group flipped, would be -15. So notice as well the use of the subscript. The use of the subscript negative here. That's essentially one way that we encourage pupils to write their negative numbers. The reason being is to make sure pupils know the difference between a negative and a minus, or a subtract or take away. So in this case, you might be asking, well, why don't we use the subscript here with that -5? Part of the reason is pupils need to be familiar with both. It is much more common for pupils to see a negative number written like that, as opposed to using that superscript here. So we need to be comfortable with both. So -5 times 4, -5 groups of 4, well, that's the same as 5 groups of 4 flipped. So 5 groups of 4 would be 20, and 20 flipped would change from positive to negative. So again, we've got -20. 6 groups of -2, well, we could jump straight in based on previous slides and think and know that that is -12, but keeping that consistent model, this is the same as 6 groups of 2 flipped. So there's the 6 groups of 2, and the one negative there, same as this, is indicating that we need to flip the 6 times 2. So 6 times 2 is 12, and 12 flipped would become -12. If we take something like this that involves 2 negatives, we keep that model the same. So we wouldn't really want to be using this word negative so many times in our phrase. -3 groups of -2. This way of writing it, which is consistent with the previous slide where we essentially take the number part, the 3 times 2, and then make use of these 2 negatives, is a really clunky way of writing it out, and we wouldn't necessarily encourage our young people to be writing like that, but it hopefully highlights the point that it's the same as what we did before. We're taking the numbers, we're going to work out 3 groups of 2, but instead of flipping once, we are flipping a second time as well. We're having to flip a second time because we've got 2 negative numbers here, -3 and -2. So what we're going to do is we're going to work out 3 groups of 2. We're going to flip the 3 groups of 2 and then flip again, because we have 2 negatives, and a negative in this case indicates a flip. So there's my 3 groups of 2. We flip the 3 groups of 2 so it becomes negative, and we have to flip it a second time so it returns to being a +6. Again, that works if we write if we draw or show on our desks using the counters the array in this different sort of orientation compared to the first one across there. Flip and flip again. So continuing that, we have -4 times -3. Well, that's the same as 4 times 3 flipped once, and flipped twice. So there's my 4 groups of 3, flipped once to negative, flipped twice to positive. Making use of the counters at this stage really emphasises this flipping idea. So the answer there is 12. Negative 2 times negative 4. Well, that's going to be the same as 2 times 4. We start off with the innermost bracket. 2 times 4, flipped once, flipped twice. So 2 groups of 4 is 8. Flip the 8 to become negative 8. Flip it a second time to become a positive 8 again. Now again, this is just for illustrative purposes for parents and carers. Here, we could still use the superscript to indicate that the answer is a positive 8. We wouldn't encourage pupils to be writing that. We would encourage them just to write this as 8 in the confident knowledge that just writing 8 means that we're talking about a positive 8. So that extends to division. So we don't have separate rules for multiplication and division. They are one and the same. So 10 divided by negative 2 is going to be the same as 10 divided by 2 flipped once. So 10 divided by 2 is 5. Flipped becomes negative 5. Negative 20 divided by 4 is the same as 20 divided by 4 flipped. So that is the negative of 20 divided by 4. And again, 20 divided by 4 is also 5, flipping 5 from positive to negative. And lastly, we've got negative 18 divided by negative 3, which is the same as 18 divided by 3, flipped not just once, but twice. So we have an answer there of positive 6. For example of what we do in the classroom, we quite often present pupils with multiple choice questions like this, where pupils will answer using their whiteboards, and we just all show the teacher at the same time, which gives the teacher a really nice overview of whether pupils are getting it correct, what they're understanding, and where the common mistakes are. Because we have in the ABCD options the correct answer, but we also have 3 of the most common incorrect answers. So we want to address these misconceptions in the classroom live at the time. So we're moving on with a really secure foundation. So negative 4 squared. When we square a number, we multiply it by itself. So essentially, we're doing negative 4 times negative 4. And the answer to that would be 16. So of the groups of questions in the assessment, we've just looked at a question very similar to that. Okay, that multiple choice question that we just looked at didn't involve the algebraic substitution, replacing the letter R with the negative 4, but we've just looked at what that calculation would be. We've also looked at the multiplication and division, and this idea of flipping depending on the number of negatives that we've got. So now let's look at multiplication and division, looking at what a zero pair is. So we're returning to these 2 colour counters, and what we will have learned about already is the fact that 5 yellows indicate positive 5, 4 yellows, positive 4, 3 yellows, positive 3. So the yellow counters indicate a positive quantity. Red counters indicate a negative quantity. A zero pair is when we have a positive and a negative. We can have more than one zero pair in any group of counters, but that's what a zero pair is, one positive and one negative. Essentially, when we're adding them together, they are creating 0. That's a really important concept for pupils going forward, not just for adding and subtracting or minusing negative numbers, also when it comes to solving equations, simplifying algebra. It's such an important concept. So we spend a bit of time going through this and doing lots of activities to really cement this in pupils' minds. Again, presenting pupils with a question like this. Is the diagram below 0? So the reason is because we have 3 0 pairs within this, which means overall we can simplify that to 0. There's no counters left out of that 0 pairing. If we have a look at this, the answer here is false. And the reason it's false is because, yep, we have a 0 pair there. We have a 0 pair there. But we have this one left out that we can't 0 pair with another positive. So that's false. Okay. Overall, this group of counters has a value of -1 because we have -1 left. We could then present pupils with something that involves a little bit more reasoning or a little bit more problem solving. So adding extra counters to the diagrams so that they do equal 0. So asking the same question in different ways to get the pupils' brains active and get them thinking in a slightly different way. So of course, we would add 1 negative. In question 2, we would have to add 2 positives. In question 3, we would have to add 3 negatives. And the way I'm presenting and laying these out, if you like, in the PowerPoint is essentially supporting pupils to pair up a positive and a negative. Question 4, we would need to add 3 positives. Question 5, we would need to add 2 positives. And in question 6, we would need to add 1 negative. So that, in a nutshell, is what a 0 pair is. What we now need to look at why that's useful by looking at adding positive and negative numbers together. And like I say, this concept of a 0 pair is so important right now. So again, here's an example of the learning intention and success criteria slide. This slide would be presented at the start of this topic because we've already discussed in a previous lesson, or maybe 2, the concept of a 0 pair and what a red and a yellow counter represent. We also have an example of previous pupils' work just to illustrate the type of learning that the pupils are going to do. So let's look at 5 add -3. So 5 add -3. Okay, let's clarify first of all whether the 5 and the -3 are positive or negative. Are they yellow or are they red? So 5 is a positive 5. Again, I haven't read out negative, so 5 is a positive 5 plus -3. Now that there might seem fairly trivial. Okay, we've read out -3, so it has to be -3. But it's important in these early stages to ensure that pupils have a really clear concept about what a negative is, what colour the counter is, and how we move forward from that. So quite literally, what we're going to do is we're going to lay out our counters on our desk. We have 5 positives, and I'm going to add into that model 3 negatives. So hopefully what you can see is that we have 3 0 pairs there. So we're weaving in this concept of 0 pairs, and we have an answer of +2. Now, like I said earlier, we wouldn't necessarily encourage pupils to present their answer with that superscript. We would encourage them just to write the 2 in the knowledge that that is a +2. So we've got 3 add -8 is the same as +3 add -8. So again, we're using the counters at this early stage. So we have +3, and I'm going to add into that model -8. And from there, you can see that we have 3 zero pairs. So the answer is -5. Again, using that superscript is fine for a negative, but we would encourage pupils to be writing it as is the most common way of writing it, which is the sort of negative in the middle as opposed to up top. -4 add -2. Okay, so both of those numbers this time are negative. So laying out the counters, we have 4 reds, and then we are adding into that 2 more reds. So even visually, this is very clear. We don't have any zero pairs in this example. There are no positive and negative combinations. There are no yellow and red combinations. We just have a total of -6. So as we're gradually working through these questions, okay, as we're doing more and more and pupils are becoming more and more confident, we do add in a little element of choice. Now that element of choice could be to continue to use these counters. It could be to do something like this in their jotters. So let's take this example, -5 add 2. So clarifying first of all, whether we have negative or positive numbers, we have -5 add +2. It's not a -2, it's a +2. So this time, pupils might not want to use the counters, but they might want to slowly get a bit more abstract, and they might want to be able to draw these in their jotters. So we could do something like this, just in black and white, using negative and positive symbols. So there we have -5, and we're adding in +2. We have zero pairs, we have the negative and the positive combination, and we have a final answer of -3. At this stage, we may well want to start to talk to classes about predicting, when we have the original question, how many zero pairs are we going to have? So that indicates a really high level of thinking. Do we have positives and negatives to begin with that will create the zero pairs? What's the number with the smallest magnitude? So for example, -5 is a smaller number, but the actual quantity, the 2 is smaller. We had less of the positives than we had the negatives. So that means that the number with the smallest magnitude is what's going to show us the zero pairs. So we would then present pupils, after a great deal of practice, a question or an exercise like this. So you might want to pause the video at this stage and give a few a go. Essentially what we've got on the left hand side there is a slide from one of our lessons where we're starting off with a negative and then we're adding another negative. So none of these in the orange section will have zero pairs, but that's for a specific part of our course. We have studied other additions where we do have zero pairs before that, and that's what appears on the right hand side in the retrieval section. So the retrieval section is all about pulling together all of the previous learning, mixing it up, getting the pupils to decide on the appropriate method, and then carrying that out in an accurate and complete way. So that's part of the learning process too, is being able to decide which method. Are we going to have zero pairs in this question? Are we not? And really drill down into the level of thinking that we need pupils to have longer term. So I'll present the answers now, if you've maybe given those a go and paused the video. And we're going to look at the next part of our learning. We could continue this and start to link it with a little bit of algebra without actually introducing the algebra itself. So we could give young people longer calculations like this and ask them to carry this out. We could use the 2 colour counters. So there's the +3. I'm now going to add in the -2, add in the +1 and the -3 and the -1. But what we've got this idea, what we could present to the young people at this stage is this idea of grouping, collecting. Collect all of the positives, for example, together. We could collect all of the negatives together because essentially we're just adding them all together anyway. And in doing so, collecting all those positives together and collecting all those negatives together, it makes it much cleaner, would be the word that I used. It makes it much cleaner and simpler to see the zero pair. That's really the one calculation that I need to do. There we have 4 zero pairs and the answer is -2. So this idea of collecting the positives and the negatives together is a concept that we use later in the course when we look at simplifying algebraic expressions and collecting, for example, x's together and y's together. Some of those are positive and some of those are negative. So again, we're building these foundations for future learning at the same time. We could expand to slightly bigger numbers. At this stage, we might become a little bit more abstract. The pupils are encouraged to add the positive numbers together and the negative numbers together, which are now displayed in red on the screen. So if we add those positive numbers together, those yellow numbers together, we would have positive 30. If we added those negative numbers together, we would have negative 20. We'd have 20 of those reds. If we then complete the calculation, 30 positives, 20 negatives, that indicates we're going to have 20 zero pairs and we have positive 10 left. Now, another way that we could illustrate this and start to add a little bit more abstractness, if I can say that, into their learning is by not presenting numbers like 30 and -20. We could use the concept of these larger and smaller circles. So the larger yellow circle here indicates that we have more positives than we do negatives because the negative circle is smaller. So what we would be asking and challenging the question that the pupils to answer if we presented those circle diagrams would be, is the answer to this calculation going to be positive or negative? And that forces the young people to think hard about, do I have more positives or negatives? Do I have zero pairs at all? If you want to do some practice, the website on the screen at the moment from mathsbot.com, the address is right at the top, is a superb website. They have something called a directed number MCQ, multiple choice question generator. So far, we've only looked at additions. So you could deselect the subtractions button at the top and, work with your young person at home going through a few of these. You simply click on what you feel the correct answer is. In this case, it would be -10. And the website will tell you if you're correct or incorrect. You then just click the new question button down here and it will present a new question, like so. If you click the button here for the counters on, it gives you these circle diagrams. So you can see that the options change from being numbers to just being, would the answer be negative or 0 or positive or either? Could it be either positive or negative? Excuse me. So in this example here, the answer would be positive because we have a bigger positive, and that means that even though we will have some zero pairs because of the negative and positive combination, we have more positives left over at the end because it's a bigger circle. So moving on, we've looked at multiplying and dividing negative numbers. We have looked at what a zero pair is, and hopefully I've clearly illustrated why that's important. We have looked at adding positive and negative numbers together, and now we want to look at subtraction or what we call minus. We certainly avoid using the phrase take away, because like I said earlier, we want to build coherence through our curriculum. We want it to be really consistent and not have, a million different rules for one topic. We want to have the same consistent rule all the time. We've never looked at taking away counters. So far we have looked at adding counters. We've always added more counters into the model and then checked for zero pairs and found the total. So when we are minusing, we want to continue that model. We want to turn the minus into an add, and that's essentially what we're going to look at. What we really, really want to avoid are rules that come in textbooks like this one. Okay, most parents and carers will have heard this rule that 2 negatives make a positive. Okay, and long story short is that rule breaks down at various points within our young people's learning. It's not actually factually correct. Okay, 2 negatives making a positive is not something that we use at all, and we would certainly discourage that from being used at home or with tutors, because that immediately creates another path and another rule for pupils, and it adds complexity, we feel, into the learning that is unnecessary. Let's build on this idea of adding, because that's what we want. We want to turn these minus questions into addition questions where we're adding counters into the model. So we start often with a known fact. So 8 minus 3. Again, I'm avoiding saying 8 take away 3. We always try to use the word minus. So 8 minus 3. Well, there's 8. If we minus 3, we know that the answer is 5. We didn't need the counters to do that. But we keep the counters in there because we want to keep this model going. So 8 minus 3 equals 5. We're all quite happy with that at this stage. We then know fact, something that the pupils are confident with. So in this case, we have 7 minus 4. Again, we don't need the counters to answer this question. We already know that the answer is 3. But let's use the counters. So 7 minus 4 is 3. So we have here the first question that we looked at, 8 minus 3 equals 5. Well, let's think about that in a slightly different way, because we want to start to incorporate this idea of adding. Instead of having this minus, we want to be thinking about this as an addition. So 8 minus 3 could be thought of in this way, where we had 8 and we added into the model negative 3. And we can see we have the zero pairs and we still get the correct final answer of 5. So we've turned what on the face of it is a minus calculation, 8 minus 3, and we have shown there that we can actually reframe this question as an addition. So as an addition of negative 3. Take this example again, 7 minus 4, it's a known fact that we just went through, the answer is 3. But let's reframe this then as an addition. So there's the 7, and instead of minus 4, let's think about this as adding negative 4. So we're adding negative 4 there. We have clearly 4 zero pairs, and the final answer is 3. So again, we've reframed the minus into an addition. So we're keeping that model going. Let's take something like 3 minus 7 then. So we start off with 3, and I'm going to add in negative 7. We have 3 zero pairs in this question, and the answer is negative 4. Take this further example, 2 minus 9. So there we have positive 2, and we're going to add in negative 9. Okay, so we're not using 9, we're using negative 9. You could think about, if we go back to previous learning on multiplication and division, we could think about this minus symbol as we need to flip the counters there. So it's not 9 positives, it's 9 negatives. So we have 0 pairs, we have 2 of them, and we have an answer of negative 7. So again, although we would be encouraging at this early stage of learning about how we minus and rewrite that or reframe that as an addition, there would be an element of choice for young people. Do we use the physical counters? Do we draw the counters? Do we need the counters at all? But we will be pushing for this concept of addition. We will be questioning pupils' understanding, even if they've come up, for example, from primary school with a little bit of knowledge of this. We're really, really keen that young people can talk to us about this idea of reframing a minus question into an addition question, because we know longer term that that's such an important little concept for them to understand. Again, so at this stage we might present at the end of a learning episode or a lesson our success criteria and learning intention slide, where we get pupils to sort of co-construct with us what this success criteria could look like. So in all the questions we've just looked at and all the practice that the pupils would have done in the classroom, we have started with a positive number. We have reframed it so that we're adding a negative number in, and we have simplified the 0 pairs because there will be some, there's positives and negatives, and then written our final answer. You could pause the video at this stage if you wanted to try a few questions, but the concept is the same. The left-hand side here, the do section, if you like, is about the learning that has just taken place, starting positive and adding negative. The retrieval section is where we start to weave and pull all that together. Okay, we weave in lots of the previous learning so pupils can practice that method selection, can understand better how to differentiate between the sort of whether there's 0 pairs or not, if we're starting off with a positive or if we're starting off with a negative, and they've got lots of decisions really to make, which is an important part of their mathematical journey. So I'll put the answers up now, and you can check your work if you did that. Let's have a look at another few. So here we're starting off with a negative number, starting off with negative 4. So it's negative 4 minus 6. So what we're going to do is we're going to add in negative 6. Okay, so we're reframing this minus question into an add negative 6. So that would be negative 10 in total. There are absolutely no 0 pairs there. I had 4 negatives. I added 6 more negatives. So we have a total there of 10 negatives. Negative 2 minus 4. So we're starting with negative 2. And we are then going to add negative 4. Again, we have no 0 pairs there. And we have a total of negative 6. Again, this just provides a little example of how we would construct the learning with the young people. So we're taking each sort of individual element or type of problem that pupils could be asked to do. We're doing an intensive period of work on that. So in this case, we've started negative and then we've added negative. Whereas in the previous section, we started positive and then added negative. The big difference here, of course, is that in the set of learning intentions and success criteria on the slide at the moment is that we don't have any 0 pairs. So again, we're adding little bits of method selection and we're adding little decisions that pupils need to make along their journey. The bit on the left-hand side is specific practice on that. The bit on the right-hand side, again, is this retrieval section, which is really important to us in the maths department. It's where we mix it up and pupils have to make these decisions and different decisions for each question. So again, I'll put the answers up at this stage. Hopefully you maybe paused that and gave some a little go. Let's move then that journey on. So let's start to look at something that's slightly different. This time we have clearly two negative numbers. So we're going to start off with the -4. This question says -4 minus -1. Now we don't want that minus, we want an add. So this time we're going to add not -1, we're going to add +1. Remember that minus there is really indicating changing the sign. It really means flipping. Okay, so we have -4 minus or flip the -1. So I've flipped the -1, here it is, it's a +1, and then we're going to simplify that. Okay, we have a 0 pair there, and the answer is -3. -7 minus -5. So we're starting with -7, and then we're going to minus -5. But that minus, we need to reframe that as an add +5. So there's my -7, and we're going to add, not -5, add +5. Okay, that minus is essentially saying flip the -5. Okay, 0 pairs then in total. Okay, there we go. We've got the 5 0 pairs in total, and we have a final answer here of -2. So right throughout this learning journey where we've looked at adding and minusing, there's one rule, and that one rule is we do every question as an add. We then look for 0 pairs and we write down the total. Essentially, we want every question to be an add. So if we take a look at this, we're starting off with -2 and we're minusing -6. So there's my -2. We're not going to use -6 because, of course, the minus says we need to add the opposite. So we need to add +6. So we have here 2 negatives, 2 positives that will 0 pair, and we are left with an answer of +4. Mixing it up a little bit, we're going to start off with +7, and then we're going to minus -5. So we're being very clear about whether the numbers are positive or negative, whether they are yellow or red. So there's my +7 that we're starting with. We need this to be an addition question. So we're going to add not -5, we're going to +5. The reason being, again, is because we don't want this to be a minus. We want it to be an add. So we've added +5, and we can see here, even clearly, just thinking about the colours, that there are no 0 pairs. So we just have a total of 12. 7 add 5. So once we've done quite a few of those, and we've encouraged people to do lots of those, we might start to summarise our learning. So -5 minus -4, that organised question is, organise, for example, your counters, and think about, be very clear. Again, I've introduced the superscript here. Think about in the question whether your numbers are positive or negative. Then we're talking about this idea of an additive inverse. Now, I haven't used that phrase yet, but essentially what that phrase is, it's all about reframing the question from a minus into a plus. So we add the flipped version, we add the opposite, is the phrase that we would often use in class. So the next part is we 0 pair, or we look for those 0 pairs. And again, with the pupils having these physical counters in front of them, we can literally reorganise them, which is really useful for lots of young people who can't quite see the maths, if you sort of understand what I mean. And then, of course, we need to simplify and we need to get the answer. So the answer there would be -1. So showing them each step sort of side by side can be quite illuminating, and we do that at various points throughout our lessons, throughout the whole course. Being able to kind of trace back your steps in this sort of way and see it in this structured way, rather than working with only one diagram and moving it about and you can't quite trace it back. So again, we might summarise the learning, getting the pupils to co-construct some of the success criteria, some of the things that we have done through that learning journey, and making that explicit and clear to the young people, but having lots of practice before and after. So in this case, this type of exercise here is one that covers everything that we have learned, adding and minusing with our negative numbers. Okay, the do section here is about the specific most recent learning, which is when we minus a negative, but the retrieval section pulls everything together. So sometimes we are just minusing a positive number, sometimes we're adding a negative number. And like I say, it pulls all the learning together and encourages pupils to make decisions. So here are the answers if you gave those a go. To summarise, we have just looked at minusing a negative and how we need to reframe that to become an addition question. It keeps the model really consistent, and it means that we only have that one rule, which is we add and we look for 0 pairs. So to conclude, we have looked at, first of all, multiplying and dividing negative numbers, and this idea of flipping depending on the number of negative numbers that we actually have. So if it was one negative number, we would flip once. If it was two negative numbers, we would flip twice. We then went on to look at what a 0 pair is, and this idea that one positive and one negative creates a 0 pair, and we can have multiple of those in one set of counters. We then went on to look at adding, and lastly, minusing. If you want to do any further work, you could explore the revision hub, and you can navigate to that on the school website by following these paths. So the numeracy and computing tab, for example, is within the curriculum section, and the curriculum section can be found just by clicking here. To get into the revision hub, you'll need to use this password, Archimedes1 with a capital A, and you'll see the first year page looks exactly like this. Most of the work we've covered in this video sits within phase 1. We have a learning evaluation booklet which summarises all of the learning that first year pupils do in that first phase, which is essentially the first 3 topics that we do. We have on the back of that exercises, practice exercises on all that learning and the answers, which is a phenomenal resource. And we also have individual video tutorials, some of which we have made using the actual material that we use in class, or we have curated and collected sets of videos that already exist online that fit with the way that we teach the course. There are so many videos out there, but try to make this your one-stop shop for everything that you need. You could also click here for the S1 Smart Targets. We have other useful videos there, which within the video we also have short practice exercises. So that concludes the Parent Carer workshop on the first year negative numbers work. I really hope that you found that useful and look forward to presenting the next session at a later date. Thank you.